In this video, I'll show how to connect a Schneider Electric SCADAPack 575 to Schneider Electric 4102 multivariable. So we'll start on the SCADAPack side. So we're in Remote Connect here. We're just going to create a new project. We're going to create a new project for the 575. I'm going to enable all the Modbus settings. We don't need all the Modbus settings, but we may need them later on in a future project, so I'm just going to enable them all. We could leave everything else as is. We just want to make sure we enable the Realflo application. That's what's going to be connecting to the 4102 MVS. So hit next. We're going to connect over Modbus TCP. I'll put the default IP in. It's 172.16.1.200. Hit next. Finish. So the only thing we want to confirm is how it's connected to the SCADAPack. So we're connected to serial port 3 on the 45, the hardwired connection here. Right here. If you click on it, it'll drill right into the settings. So in the settings, it's set up for Modbus RS45 two-wire, and the baud rate is 9600. So everything's looking good here. So we could go and double check the connection that we have. So here's the back of the 4102. We are connected here to the SCADAPack 575. So the positive goes to the positive and the negative goes to the negative on serial port 3 of the 575, and it comes in right here. We also have the power wired in, so it's powered up. We want to make sure this 45 switch is set to 45, not 232, because we are using 45. And then the RTD connection is connected to the two R's and the IRET, which you can see here is the return. So essentially we have the white wire from the RTD connected to pin 3, and then the two red wires connected to pins 2 and 1. So now we have that connection all figured out. We have the SCADAPack all set up. We could just go online with the SCADAPack and write the config that we have to make sure that's in the SCADAPack. Hit refresh. We're showing we're connected. We'll go write this config. Hit OK. Just going to stop the logic, but this is a test bench SCADAPack, so it's fine. Hit OK. Hit refresh again. So everything's good. So now we could go into Realflo, and then in Realflo we'll create a new program step by step, or new project step by step. So at next, we do have a flow computer. Our flow computer in this case is a SCADAPack 575. We'll choose the communication settings. It's going to be Modbus TCP, just like Remote Connect is. That'll be 172.16.1.200, and then hit OK. Hit next, next, and then give the flow computer name. So this will be the whole SCADAPack flow computer name. Typically it's a site ID, so just hit site ID. We only have one flow run, so select one, but you could go all the way up to 20 on one SCADAPack. Hit next. And then hit the type in the flow run that you're creating. So this will be 4102 gas is what we'll call it. Hit next. There'll be a gas flow run. We're going to keep it as AJ392, AJ894, and forward by value. That's fine. We're going to select metric 1 for both the input units and contract units. You can change the units, the input units and contract units, to whatever works for you, but you could go through all of these parameters to see what works best. We're going to use COM3 on the SCADAPack 575 is going to connect to a 4102. So you hit next. The upper operating limit on this 4102 is 75, and the low cutoff will be 0.5. The upper operating limit of this will be 10,000 for the static pressure, and then we'll use gauge pressure, and then I'll use my elevation to calculate the atmospheric pressure. Select no here. For the temperature, we're going to go -20 to 100 will be the span. The lower operating limit and the upper operating limit. It'll be time weighted. We'll roll over at 8 AM. We'll keep the standard base conditions. Those all look good. Hit next. Yeah, we want to log for any AGA8 change, and then we'll calculate the values for the relative density and heating value. And then we'll enter each component. Maybe this is 99 and this is 1 for methane and nitrogen, but obviously you'd put in your gas composition here. For the orifice, we'll use stainless steel for the orifice material and carbon steel for the pipe material. The orifice diameter will be 25.4, and then the pipe diameter of 50.8. Hit next. We'll leave the dead bands at 0 for now. Now we'll connect to the sensors to configure them as well. Hit next. Use the sensor we just created, so hit next again. So it'll be column 3. We're looking for the one sensor. Select next. So right now I picked up this sensor here. Typically the address would be 99 when you get it from the factory, or if we factory boot the 4102, but I was playing around with the sensor previously, so it's addressed to 5, so that looks good. You can change the address if you want. Say 5 didn't work, you can go to 4 or whatever it might be. But you never want to leave it at 99, because if you put another MVS on the same loop, you will never be able to find it. Hit next. It's all looking good here. We'll finish. Select next. Select next again. And now it says, do you want to compare the current configuration, so what's currently on there versus what I created? I want to select no. There's nothing really on the SCADAPack, so I'll just be comparing it to nothing. And then it says, do you want to write the config? So I'll go next and write the config. And then depending on how the SCADAPack's currently configured, it's asking you, there's only one flow run that I created, but the current config has 2, so that's fine. And then we could save it. You could save it to a certain spot on your computer if you want. I'm just going to save it to the default location and hit finish. So now you could hit update readings here. You'll be able to see the live values. So you can see the temperature is about 19 degrees because we're inside. Yeah, we have your static pressure. Differential pressure is at 0, so I'm going to pump this up a little bit to see that change. So now you saw the differential go above that 0.5, and then the alarm went away, so everything's good. We got our static and differential pressure. In the next video, we'll go through how to pump up the transmitter to test the static and differential pressure. Thanks for watching this video.